Hey guys, I want to start out with a review of U substitution, which is from section 5.5. This is usually covered during the last part of Calculus 1, and people typically find it to be one of the more difficult things in Calc 1. So I think it's a good idea for us to take at least this first sort of day of class and review this as an idea. Um, U substitution works when you have a nested function. So what I've got here is I've got U inside of the function f, and the derivative of u shows up over here on the outside of it. And we've got a constant over here, and it's done with respect to x. So remember, what you do is you find u. It's nested inside of another function. You take the differential of it to get du equals u prime times dx. And then you do something to, basically what these next few things say is rewrite this completely in terms of u instead of in terms of x. So let's jump down here and do this example. So on this example, 0, 0, 1, let's see, our u is going to be the 1 minus x to the fourth because that's inside. And also its derivative would be negative 4x cubed, and a multiple of that is on the outside. So I'm going to let u equal 1 minus x to the fourth. Derivative of that is minus 4x cubed dx. And let's see, I'm going to rewrite this. This is 2, 1 minus x to the fourth. Well, I'm just going to rewrite the whole thing here. I really just sort of rearranged it a little bit here. And now, down here, I want to solve for x dx. If I do that on this, x cubed dx, left the cube off before, x cubed dx is minus 1/4 du. So now I can use all this stuff in the box to rewrite the integral. I've got a 2. 1 minus x to the fourth is u, so this is 2 u to the u squared, and then x cubed dx gets replaced with minus 1/4 du. So let's see, I can combine the 1/4 and the half. If we put those two together, we get negative 1/2. And since that's a constant, I can bring it out front. Integral of u squared du. And so this integral is easy to do. Integrate u squared, you get 1/3 u cubed plus c. And so we've got minus 1/6 u cubed plus c. And we're essentially done except for you want to put it back in terms of the variable that you started with. So we've got to replace that u with 1 minus x to the fourth. So this is minus 1/6 1 minus x to the fourth cubed plus c. Like that. All right, let's do another one. This next one might be a little trickier because what's our inside function and what's its derivative? Well, our inside function here is ln x because it's inside that radical, and the derivative of ln x is 1 over x dx. And so what I'm going to do here is since that x is in the denominator, that is 1 over x dx. So what I can do is rewrite this as, let's see, square root of ln x times 1 over x dx. And now I can replace this. This just becomes u to the 1/2, or square root of u, whichever you want to call it. I'll use the 1/2. And then 1 over x dx is du. All right. So let's see. When we do u to the 1/2, when we do the integral of that, we have to add 1 to it. And then we divide by that same number. So what we've got here is on top u to the 3/2 over 3 halves. So that gives me 2/3 u to the 3 halves plus c. And I'm going to rewrite that as 2/3. This last step is not optional. You have to put it back in terms of x. 2/3 times natural log of x raised to the 3 halves plus c. And that's our answer. All right, this next one, sine of 4x. If you just take the integral of sine, you get negative cosine. Here, our inside function would be 4x. Our du is going to be 4 dx. And so this is just going to be equal to, let's see, sine of u. The dx is 1/4 du. So we wind up with 1/4 times minus cosine of u plus c. And just put it back in terms of x. That's all there is to it. All right, let's stop here and we'll look at the definite integrals in the next video.